This is the opening for the lesson on 12-3 in geometry. And this is going to have a couple probability problems. One's going to be a geometric probability problem. Another one's going to have a bag with several different colored balls in it that you're going to find the probability of. So the first problem says, if a ball lands at a random spot in the infield, so this is the infield, what would have been a square here, but has corners cut out that are half circles. What is the probability if the ball lands at random in that infield, what's the probability it will land on grass? What is the complement of landing on grass? Now, first of all, I want to point out that the sides are all 60 going up here if they were to go all the way to the corners. So this would be 60 if it were going all the way to here, and then 60 all the way to here from there to there. So where the bases would be is part of that. So you got to think of that as 60 going all the way to there, 60 going all the way to there, and then what you want to do is realize that when you've got these problems, you're going to figure out what these are. And I want you to think of these just as an estimate. You can think of these as half circles instead of worrying about this little corner here. So just estimate this is a half circle, this is a half circle, this is a half circle, and use this as a full circle when doing this problem. It will give you an estimate of what the probability is. The second problem that you're going to be doing as part of this, it says if a bag has 2 red, 3 green, and 10 blue balls in it, find the probability that green ball is pulled out of the bag, put back into the bag, and then a blue ball is pulled out of the bag. So I'd like you to try both these probability problems with the people in your group, figure them out, and then you can come back later to the video to take a look at the solution to see if you did it correctly. So pause the video and you guys try it in your group. Now that you've tried it, let's go ahead and take a look at the solution. So again, if this is 60 feet on each side of this square, if it was going all the way to the corner, what you do is you'd figure out the area of the square first. That's the whole area. So I'll put the square down here, and that's going to be 60 times 60, which is, when you multiply that out, you get 3,600. Now let's do the area of the circles. Now I'm going to do one circle. So area of one of the circles is going to be, you're going to take the radius, which is 8 feet, and you're going to do 8 squared times pi r squared. That gives you 64 pi. Okay, now when you take that, notice how many circles I have. If we're estimating this corner as being about a half a circle, okay, so we're going to take 1 1/2, 2 halves put together is 1, 1 1/2, and then this circle in the middle where the pitcher's mound is, that gives me 2 1/2 of the dirt areas. So I'm going to multiply that by 2.5, and that gives me, when I multiply that, 160 pi. This is how much the dirt is. Okay. So if I want to figure out what the grass is, probability of grass, of it hitting grass, okay, first of all, I'm going to take the whole area, which is 3,600, and I'm going to subtract off the dirt areas, 160 pi. That will give me how much grass there is. And we divide that by the total area, which is 3,600 still. And so doing that on your calculator, remember to put this in parentheses when you do it. Do the numerator of a fraction in parentheses, 3,600 minus 160 pi. Get that answer, divide by 3,600. And when you do that, you get approximately, when I do that answer, I get about 0.86. Then it asks you, what is the complement of landing in grass? Well, the complement is landing in the dirt. If it's gonna, we said at the beginning, it's gonna land in the infield. So the complement is what is not grass. That's gonna be the dirt. So if we want the probability of it landing in the dirt, which it doesn't ask you, so if you didn't answer this question, that's fine. The complement is the dirt, landing in the dirt. You're going to do 1 minus landing in the grass gives you what when it lands in the dirt. And so that turns out to be 0.14 for its probability of landing in the dirt. All right, let's go up to this problem with pulling the balls out. So when we add these up, we get a total of 15 balls for this. So when we do our probability, that's going to be what we divide by. So the probability of green, which is the first question that's being asked of you, there's 3 green, and it's over 15 total. So it's going to reduce down to 1/5 as part of that. Okay, then it asks what the probability is of blue. So the probability of blue, there's 10 blue divided by the 15 total. Now I'm going to be kind of smart here, and I'm going to go ahead and reduce it just to make the problem less, because I'm going to end up multiplying these fractions, and otherwise you're going to have large numbers. So let's go ahead and reduce this one also. A 5 goes into each of these two. So I take a 5 out, and you end up with 2 on the top and 3 on the bottom by canceling out a 5, just like we canceled out a 3 out of these two. So because these are independent events, because we took the first one out and we put it back in, and then that means that the next events can be independent of it. We have all the balls back in the bag. So what we can do to get the probability of getting, it wants to say probability of that a green's pulled out. So that's going to be probability of green and blue. They're independent events, so we're going to multiply them together. So you can get 1/5 times 2/3, and that's going to equal 2/15 for my probability. Again, you could list that as a decimal if you'd like to. So these are the 2 answers to the opening problems. Good review of geometric probability, and then just our other types of probability, including independent events, where if you have independent events, you multiply the 2 probabilities together.